20%. That is the share of the world's population that speaks English at home. Now here is the number that matters. Nearly half of all training data used to build the world's major AI models is in English. Think about what that means. The tool everyone is being told will transform their economy was built primarily on the language of 1 in 5 people. That is not an accident. It is an architecture. And it has consequences that compound every single year. Last episode we established that AI is concentrating power, that a small number of entities control the infrastructure, the models, and increasingly the terms of access. Today we go one level deeper, because the question is not just who controls it, it is whether the gap that is forming can actually be closed. The evidence is not encouraging. Start with compute. We know frontier AI requires frontier chips. We know those chips are subject to export controls that sort the world into tiers of access. Here is the number most people have not seen. According to analysis from the Center for a New American Security, by 2027, countries operating on older export-approved chips could face a 10-fold cost penalty just to train models at equivalent capability. 10 times the cost for the same output. That is not a gap. That is a structural wall. And it is being built right now through licensing decisions made in Washington. But compute is only one layer. The deeper problem is what happens after the model is built. AI systems improve through use. Every query, every correction, every piece of human feedback makes the model better. This is called the feedback loop, and it runs faster for the systems with the most users, the most data, the most interaction. The systems already at the frontier are not just ahead, they are pulling further ahead with every passing day. The systems behind them do not just need to catch up, they need to catch up to a target that keeps moving. Now add the language problem. This is the part most people do not see coming. GPT-3, one of the foundational models that shaped this entire industry, was trained on data that was more than 90% English. 90%. For a tool the entire world is now using. A randomized study published in Scientific Reports tested AI-generated business content across English, Arabic, and Chinese. Same tool, same task. The outputs in Arabic and Chinese were measurably lower quality, not slightly lower, measurably lower, which means 2 people in 2 different countries using the same AI product are not getting the same product. One is getting a precision instrument, the other is getting a translation of one. Stanford researchers who study this put it directly. They said they anticipate these gaps will get bigger, that as AI transforms workplaces globally, workers fluent in English will advance, while others face technological barriers to employment. This is not a fringe concern. This is coming from one of the institutions that helped build these systems. There are over 7,000 languages spoken in the world. Only 20 are considered high resource enough to train AI systems effectively. For everyone else, the model either performs poorly or does not work at all. And here is where it gets structural. Low resource languages have less data online. Less data means worse models. Worse models mean less useful output. Less useful output means fewer people use it. Fewer users means less feedback. Less feedback means the model does not improve. The gap does not just persist, it deepens by its own logic. Now layer the sovereignty question on top. A government running public services on foreign AI infrastructure is not just accepting a capability gap, it is accepting something else entirely. As the OECD noted directly, relying on foreign AI systems means accepting that access can be restricted or withdrawn at any time. That data protection depends on foreign law, and that the worldview encoded in these systems comes from design decisions made in Beijing or San Francisco. Not in Nairobi, not in Jakarta, not in Bogota. This is not hypothetical risk. AI systems encode values. They encode assumptions about what is normal, what is correct, what is relevant. When those systems are built in one cultural context and deployed globally, the worldview travels with the model. So what does closing the gap actually require? It requires frontier compute, which requires either building domestic chip capacity or securing access before restrictions tighten further. Both take years, both require capital. Most countries do not have at that scale. It requires training data in local languages, which requires digitizing content, building data sets, funding research that the global market does not currently reward. It requires the feedback loop, which requires enough users to generate enough data to improve the model. To attract more users, you cannot buy your way into that loop overnight. You have to grow into it. And growing into it takes time that the frontier is not waiting to give. This is what makes the gap potentially permanent. Not that the technology is inaccessible, it is accessible, relatively cheaply. But accessible and equivalent are not the same thing. A country can access a version of frontier AI. It may not be able to access the frontier itself. And the frontier is where the leverage is. The frontier is where the decisions that matter get made faster, where the research compounds, where the economic advantage builds. Consuming AI from a distance is not the same as operating at the edge of it. Infrastructure gaps in history have a pattern. They look temporary at first, and then one day, they do not. The question for the next decade is not whether AI will matter. That is settled. The question is whether the world that builds it and the world that consumes it become two permanently different worlds. In the next episode, we look at who actually holds the controls, not just over the technology, over the decisions, who is shaping how AI develops, what it optimizes for, and who it is built to serve.